Hi, everyone. This is part two of our discussion of human impact on the environment. Today, we are going to pick up where we left off with pollution. We're going to focus on air pollution, and then we're going to talk about global atmospheric changes, including global warming and ozone depletion, which are easily confused. So please do note the differences that we'll go through. So air pollution is basically particles or chemicals in the air that are unhealthy and unsafe for living things. Often it's caused by burning, combustion, specifically of fossil fuels. Fossil fuels are coal, oil, gas, and burning these fossil fuels, whether it's a factory, a car, power generation plants, they're going to release very specific chemicals into the atmosphere, many different kinds. Two specific ones that I'd like you to know are called sulfur dioxide and nitrogen oxide. And sulfur dioxide and nitrogen oxide are specifically chemicals that lead to causing acid rain. And acid rain is not always in rain form. It can also be in hail or snow. So it could also be called acid precipitation. So these two specific compounds, sulfur dioxide and nitrogen oxide, are the reasons that acid rain occurs. And I'm sure you've heard of acid rain. Well, what is acid rain? You know what acids are. If you remember back to our biochemistry unit, we learned the pH scale. And something that's a low pH is called an acid. It is acidic. Something that has a higher pH would be alkaline, the opposite. And so these chemicals, when combined with water in the atmosphere forming rain, are going to reduce the pH level of that water. And this acidic pH, which is anything 6 or lower, that's acidic on the pH scale, is most harmful to the organisms that are in direct contact with rainwater. So this is organisms in lakes and ponds, as well as plant life. Plants directly absorb rainwater through their roots. And if you recall, the bad thing about pH levels changing in living cells is that it can be disruptive to enzyme functioning. Now, this is not a problem that you have to worry about directly to you getting rained on with acid rain. It's not like, oh, this rain is so acidic, it's going to burn my skin off. No, the organisms that are most directly impacted are those that directly take in or swim in the water that is acidic. This is just a little demonstration of how acid rain can form in one location, but can actually be carried and moved with the clouds and end up raining down elsewhere. So factories that are far away from us can produce these chemicals, the sulfur dioxide, the nitrogen oxides, get into the atmosphere, and then those chemicals interact with the water in the atmosphere, and as the clouds form, that rainwater is becoming acidic, and then clouds move until they are dense enough to actually release the rain, and then wherever the rainwater falls is where those organisms are going to be exposed to acid rain conditions, and it can kill plant life and pollute rivers and streams. It can do some damage to stonework or to paint on your car also. Another type of air pollution is clearly visible in a picture like this, and this is called smog. It's basically smoke and fog, smoky fog, smog. This is produced by excessive burning of fossil fuels, and this is really harmful to breathe in. Smog is worse in populated areas, more densely populated areas like big cities. This is an example of pollution in Hong Kong, and it has been so bad in the past that they actually made this fake skyline photo backdrop for tourists to take their pictures with. So if you look carefully here, you see the people posing in front of these photos of what the skyline should look like. But up above here, you see what the skyline actually looks like on this very smoggy day. All right, so the next two human impacts we're going to talk about are really often confused by people because they both have to do with the atmosphere. However, it's two separate problems with two different causes and two different outcomes and issues from these problems. So please don't confuse them. Global warming and ozone depletion. So first we're going to talk about global warming. To understand global warming, you have to understand a concept called the greenhouse effect. Now, if you've ever heard of a greenhouse, basically a house made of glass. And the purpose of a greenhouse is that it's made of glass so it lets light in. So you can grow your plants in a greenhouse all winter long. It doesn't matter how cold it is outside because they get light from the sun And the glass traps heat. So it's not cold in a greenhouse. It's actually very warm in a greenhouse. And so this is great for plant growers to keep growing all year long. Now, the effect that we're talking about here, on a global scale, the greenhouse effect is happening due to, instead of glass being around our Earth, it's going to happen due to the Earth's atmospheric gases, some of which trap heat. And we're going to talk about those gases. So the Earth, you can think of it like having a blanket of gases in its atmosphere, and some of those gases are really equipped at trapping heat and not letting heat escape out into space. And therefore we see an increase in the greenhouse effect, warming up of our planet, when these gases are higher. So here's an image visualizing the greenhouse effect here with our planet. Our planet Earth has a protected atmosphere. That atmosphere is made up of many different types of gases, and the gases penetrate the atmosphere. The sun penetrates the atmosphere, so heat penetrates the atmosphere, warms our planet, and many of the gases trap the heat and don't allow it to escape. One of the most commonly known greenhouse gases, and the one that you must be most familiar with, is carbon dioxide. Now, carbon dioxide gets villainized in conversations about the greenhouse effect and about global warming. Please remember, from a whole biological point of view, carbon dioxide is a vital gas for life as we know it on our planet. Please don't let this come off across as carbon dioxide being the evil villain here. We just have to manage our production of it better. Now, carbon dioxide we know is vital for plant life, photosynthesis. We need it on our planet. But when there's excess of greenhouse gases like carbon dioxide, and there are others like methane, then we see the trapping of heat happening, just like the glass roof of a greenhouse. And so these heat trapping gases are called greenhouse gases. If it weren't for the greenhouse effect, we'd have a problem. The greenhouse effect is important at keeping our Earth at the right temperature. We need our oceans to be kept in liquid state. If we didn't have the greenhouse effect and we didn't have a certain amount of heat being trapped on our planet, it was all bouncing off, it would be too cold to support life as we know it. So it wouldn't be the beautiful planet that we know with life as we know it without the greenhouse effect. The problem happens when it's magnified by excess levels of the greenhouse gases. So this problem, when we have excess levels of greenhouse gases, is a global atmospheric change, sometimes referred to specifically as global warming, when the temperature of our planet is changing. It's increasing, and due to excessive greenhouse gases trapping heat. Now, where are these excessive greenhouse gases coming from? CO2 is produced as a normal byproduct of some chemical reactions. Whenever you exhale, you breathe out CO2. It's a byproduct of respiration. Whenever you burn a campfire and roast your marshmallows and make those delicious s'mores, you are releasing carbon dioxide. Carbon dioxide is released from fire burning. It's called combustion. And the reason that carbon dioxide is released from burning fossil fuels is also combustion. The cars you drive around in mostly have what we call combustion engines, where they rely on a fuel source, mainly gasoline, and that gasoline is from the fossil fuel oil, after being petrol, actually, after being refined in oil refinery plants. And we burn that organic matter in order to release energy to move the car. But in doing so, it's a form of combustion and it releases CO2. And therefore, we do have more CO2 in the atmosphere since the Industrial Revolution and the burst of technology and use of all of these energy fuel sources. And so greenhouse gases can trap heat that normally would radiate into space. There is a quick video clip here that I thought I embedded, and I can probably show you in the recording. Oh, let's see. See if it's going to work.
Let me quickly review for you how this works. So again, the surface of the Earth is heated by the sun. The amount of energy that comes out of the Earth, geothermal energy, is a few thousand times less than what actually comes from the sun. So in certain places it can be important, but overall it's the sun that sets the Earth's surface temperature, not the internal temperature of the Earth. And when the sun shines on the Earth, some of it is actually reflected back to space. Again, more of it if it's on an ice-covered part of the Earth or where there's lots of clouds. And some of it is then absorbed by the Earth. And when it absorbs solar energy in the visible spectrum, what happens is the Earth heats up in response because it's absorbing energy. And when objects heat up, they emit their own radiation, but in a longer wavelength. And so that radiation then heads back towards space. If the Earth had no atmosphere, it would be about 30 degrees colder. So we would actually have a frozen planet. We are habitable because of our atmosphere, and because our atmosphere has some greenhouse gases, in particular carbon dioxide and methane, the most important of which is actually water vapor. Water vapor is interesting. We don't often talk about it as a greenhouse gas, but the reason it's important is it's like an amplifier. It turns over quickly. It lasts in the atmosphere hours to days to weeks. And so as a result, you can think of the other greenhouse gases, carbon dioxide and methane, as the dial, say on your stereo, but it's the water vapor that amplifies the effect because it turns over so quickly. And so what happens is these greenhouse gases, they absorb some of the infrared radiation, the long wave radiation, and re-radiate it both back to space and downward, but they act like a thermal blanket. So they essentially keep the Earth's surface warmer than it would be otherwise. And that's how the greenhouse effect works. And again, this isn't just a theory. We can actually say this is what causes Venus to be 460 degrees Celsius. We know this is, in fact, in the laboratory, we measure carbon dioxide by looking at how it absorbs long wave radiation.
Okay, so continuing, this excessive heat and higher temperature on our planet can be problematic. So some people say, oh, I like it a little warmer. What's 1 degree? What's 2 degrees? No big deal. But if the temperature increases too much, it could cause the ice caps to melt. And there are many organisms that depend on the ice caps. The adorable fuzzy polar bear has become kind of the face of global warming as a problem because the polar bear has lost a lot of its habitat, its hunting habitat, via these ice caps. If enough ice melts, it can affect sea levels as well as salinity of those oceans. And this can cause problems for any organisms that live along coastlines. And we could end up seeing endangered species and even climate disruption further magnified due to ocean currents being affected from these changes. So it could be a problem. It is a problem. And so the sources of carbon dioxide that we have, I mean, some of them are just, we can't do anything about. Respiration and decay, they just make CO2. You can't stop breathing to stop making CO2. But there are some things that we can control and we can try to impact our production of CO2 with. And mainly this regards generation of energy. So when we generate energy, for example, you plug in your phone to charge in your electrical outlet, you're getting energy, electricity from a power plant. And that power plant is generating energy through some form of combustion. That power plant is burning coal or burning oil in order to produce energy. Now, this is assuming it's a fossil fuel-based power plant, which most of ours in this country are. There are alternative energy sources that some power plants use, such as geothermal or hydropower. That's a subject of an ed puzzle I'm going to have you do this week as well, alternative energy sources. But most of our energy comes from combustion. So cars burning gasoline, factories burning fossil fuels, and power plants usually burning fossil fuels. Sometimes also from deforestation techniques such as burning methods. So if we need to clear a plot of land for human development and expansion, or for farming, they're going to expand coffee fields somewhere. Sometimes the method of clearing the land is burning. And burning is faster than cutting down the trees, but it's going to produce more CO2 via combustion. And so some of these are within our control, even though some of them are not. Here is a graph that just illustrates the amount of CO2 produced, the amount of carbon produced, which is our main greenhouse gas, by sector. So this first bar, I don't know if you can read it, is the industrial sector. There we go. The second bar is transportation, so buses, cars. The third bar is residential. Then we've got commercial, which is businesses, stores, and agricultural, so planting in the fields and raising crops. So these are all various ways that CO2 gets produced. Now, science has been, I don't want to say confused, but wishy-washy to some degree the last few decades about the Earth's temperature and possible results and what we have to worry about. These Time magazine covers are really interesting to me to see. Back in the 1970s, we were worried about the temperature eventually leading to a new ice age, a mini ice age, and cooling, whereas more recently, we have more of a problem of worrying about warming. Just a food for thought. It's a stigmatizing topic for some people to talk about global warming because they don't want to listen to the opposite possible opinion on whether or not global warming is mostly due to human problems or mostly due to the natural cycling of the Earth. That's the common debate and controversy that you hear surrounding global warming. The second problem that I don't want you to confuse with global warming is specifically increasing temperature of the Earth and the problems that lead from that. The second problem is ozone depletion. And ozone is just another form of oxygen atoms in O3 instead of O2. O2 is oxygen gas that we and many other organisms need to live, to breathe to live. O3, ozone, is oxygen. Now, oxygen is in our atmosphere to about 21% of our atmosphere. And oxygen is going to be able to react and form ozone in our atmosphere. So we actually have a layer of ozone gas in our atmosphere. And it's actually a really great, important, helpful layer of gases. Just like the greenhouse gases are helpful and important, the ozone gas is important because ozone actually is a way of blocking ultraviolet radiation. If you remember from our genetics unit, we talked about ultraviolet radiation being problematic for living tissues because it can cause damage to DNA, it can cause mutations. So there are different ranges of ultraviolet radiation, so UVA, UVB, UVC, different ranges of wavelengths that do come from the sun. And our ozone layer in our stratosphere, technically up in the air, is going to be able to block most of the UVC rays, most of the UVB rays, and some of the UVA rays from reaching our Earth's surface. And so that's important for us in protecting us from excessive radiation exposure, protecting us from possible DNA damage, and not just us, other organisms as well. All life is made of DNA, and the DNA being damaged is problematic to any living thing. What's interesting about these pictures that are highlighted here with different colors is where you can see the wearing away of the ozone layer in various parts of the planet. So the biggest hole in the ozone layer is actually in the southern hemisphere, and it is mostly over Antarctica and a bit over Australia. That's that bluish purplish hole you see there on those images. So ozone depletion is the breaking down of this protective ozone layer of gases we call the ozone shield. And that breakdown is going to cause more UV radiation to be able to get to our Earth's surface. And the reason that shield has been destroyed is because of these man-made gases that are called chlorofluorocarbons. Big word there. You can say CFCs for short. These chemicals are the main reason that we've discovered that we've seen reacting with ozone and breaking it down. We've used these chemicals in the past in our air conditioning units, refrigeration, and aerosol spray cans. But when we discovered they were problematic for the ozone layer, we did ban their usage. And so we have waited and have seen a recovery of those holes and those patches in the ozone shield. So it's doing better thanks to us recognizing the problem and making the regulation and the effort to change. All right, so the problem of having a depleted shield is you have more UV radiation, more mutation, more skin cancer risk, destruction of organisms that are directly dependent on sun, like plankton and algae, and they're important to everyone that needs oxygen because they respire, they do photosynthesis and release oxygen for us to do respiration. Crops that are dependent on sun can be disturbed as well by these mutations from excess UV radiation. So this is a good slide to just help you compare global warming and ozone depletion, just because it's a commonly confused set of problems. They're different problems with different descriptions, different causes, and different effects. So if you're watching this recorded, please just pause it for a minute and read through and make sure you realize that they are separate issues. Lastly, we need to make sure that as individuals and as a society, we take action. There are certain things you can do as an individual that that you can do directly, immediately, and there are certain things that you can't control, and you need bigger change at a societal government level to make actions. So we got to keep in mind that technology we use can be helpful, but it can also hurt the environment. What do we mean? Well, technology, we invented factories, we invented the automobile. That was helpful to society growing and people prospering and earning more and being able to reproduce more, but it is harming the environment in certain ways as well. But then we have technology that is aimed at helping the environment, development of solar panels, for example, as a method to try to help trap a different source of energy, the sun's energy, and use that instead of other types like fossil fuels. So technology can do both help and hurt. To solve some environmental problems, we have to consider what we call trade-offs. If you've never heard this word before, just in regular plain old English, it just means when you have to give up something in order to get another. So if you want to, build over the swamp, this I'm going to talk about Disney World because I love Disney World and I miss them so much. If you want to build Disney World was built over a swamp in Florida. Most of Florida is swamp. So a lot of that swampland had to get destroyed in order to build Disney World, to build the roads, to build the actual parks, to build the parking lots. And so a lot of organisms had to get displaced, and plant life had to get cut down, and waterways had to be filled or redirected. And so that is going to have an impact on the natural environment there. So we have to consider that when we're doing these types of projects. We have to say, what's the trade-off? What are we losing? What are we impacting in order to gain something? We must study the impact of these new technologies before we use them. That's kind of a given, if you ask me. And we have to keep in mind that our decisions today can affect future generations to come. And the planet is the one that everybody shares. So that's it for the mechanisms of humans impacting the environment. Thank you for listening. I do have a few practice questions that I'm just going to roll through now. And if you want to watch them and try them, I would suggest hitting pause, because I'm not going to read through, I'm not going to talk through. I'm just going to let them pop up on the screen, and you can pause it and read it yourself, and then press play if you want to check the answer. Just a few, just for practice. Okay, thanks. Miss you. Remember to pause it to read it. And here comes the answer. Pause it to read it. And here comes the answer. Pause it to read it. Here comes the answer. Pause it to read it. This is a longer one. Here comes the answer. Okay, thanks for listening.